Chat. All right. So the goal for today is to get through the rest of the digestive system. Finish up the histology that we have, and then we should have some time. Give you guys some time to study and kind of make sure that you close the loop on everything that we looked at over the last week and a half, so that you're ready to go take it home and study on Thanksgiving break, right? That's kind of the goal. So when you come back from Thanksgiving, you've got the reproductive system, and then we'll the final. If you want to send you off today as if you're getting ready for a practical on the digestive system. Ready to be on break? Yeah?
Now I have a question. Do you know when our finals are?
I do.
Can we know?
There is
No,
a
Yeah, but
lab
like,
final is on Monday, of finals
Monday.
week during your normal lab time.
Okay.
And your lecture final is on Wednesday of finals week during your normal lecture.
Okay, thank you. Dude, you just said.
no, but I forgot
So
which
you'll
group.
be done
Which group
by
are we?
Wednesday of finals week at about 10 a.m. Maybe early.
Which group
are
Speed group. Oh no, he's
No,
gonna,
but
oh,
like
he's in
which?
the center. No, he hasn't chosen yet.
What?
Because that's
like,
what. Because it's the two groups, so that's why I was like,
The
which one
lab
are we?
Final, yeah. So lab is on Monday.
Mhm.
Lab final's Monday.
But he hasn't chosen which group's gonna go first yet.
Cause it's A and
How
B.
are we going to decide that?
Jeopardy.
Huh?
Fight.
Play like a game of dogs or something.
Or
They're
Jeopardy.
they're looking
Like-
pretty smart. You should let them go first. Their brains are looking pretty ginormous.
You know what?
They
We
got
actually,
this.
in this lab, we might have a few enough people that we could actually probably do it in one big group.
Okay, that's
Does
so
that mean
nice.
we all go first or all go?
Thanks, Dr. Russell.
No, you just go take it at 1 o'clock on Monday at finals week. What do you mean all go first?
Two
All go
call.
at once. Is that how you measure things in Canada?
What?
Is that how you measure things in Canada? One
Yeah.
group, which one goes first? All right. Anyway, yeah. So no, yeah, you guys are a small enough group that might be able to do the whole lab final on Monday at finals week in one group. We can take a look at it after the break. We've got some time after the break. We can take a look at it, but I think there's few enough of you guys that we could probably do it in one group. So we won't do. We usually start your lab exam by doing the group portion of the lecture. We won't do that this time. We'll just have your lab exam. And then on the day of the lecture final, which is on Wednesday, you guys will take your individual lecture exam. And then I'll give you guys the opportunity to get into your groups for that second part of it. So that'll be all during the lecture. So that's how we'll do that. But yeah, you guys are a small enough group. We might be able just to fit. I don't do it. The main reason I do two groups at the beginning of the semester is because a lab exam might only have 20 stations, but there's like 32 of you guys. So it's like, what am I going to do with the other 12 of you guys? So I just divide you into two groups that way. But there's few enough people in this lab section that I think we probably could get by with just one group for the lab final. So we'll see. We'll talk about it after Thanksgiving. But I've been thinking about that, but I think we probably could do that. That way you're all out of here. And we could even decide on a start time. We could do like 1:07 if we wanted to, right? If we're all doing it at once, we could just do it at like 1:07 or 1:23 or something like that. We could get crazy and kind of do that. So, anyway, we'll talk about that after the break. All right, let's go ahead and get started. So today we do want to finish the digestive system, and we finished class, I believe, on Wednesday by looking at the epithelium of the small intestine under the microscope, and we looked at those Peyer's patches. So we kind of have finished the small intestine anatomy, and what we want to do now is we want to get into some of the large intestine. I know that you guys have already looked at the gross anatomy of the large intestine, the ascending colon, the transverse colon, and so on and so forth. So what I wanted to do then is I wanted to go ahead and just have us dive right into the microscopic anatomy of the large intestine. So here in just a second, I'll have you guys get a microscope. We have a couple of slides. It doesn't really matter which one you pick. So we've been looking at the digestive composite slide, and that one does have a small intestine or a large intestine on it. So you can use that one. I'll put that up on the board there in just a second. We also have a second slide over here that's just large intestine. Like I said, it doesn't really matter which one of the two you pick, so you can surprise me. They're really the same. It's just large intestine. So you can either pick the digestive composite, and then we'll finish that, or you can pick the large intestine, or you can pick both and look at both of them. But nevertheless, we have that. So let's grab a microscope, let's grab some slides, and let's take a look at the large intestine under the microscope.
Thank you, Christian. Thank you. We'll go ahead and start. You should find something that looks kind of like this under the microscope. One of the things that you'll see is the villi are gone, right? The villi are just a small intestines thing. So we don't have that here. So what I'm going to do is I'm going to let you guys look. I'm happy to come around and make sure you're looking at the right thing. But what I would like you guys to do is now that we've looked at a lot of GI tract slides, try to identify your 4 layers that you're looking at. Let's identify the mucosa, the submucosa, the muscularis externa, and the serosa. On my slide that I've projected for you, you can see all I hear
4
you
of them.
get that question wrong.
Try to start with
Back
that.
and hits you.
Try to do it on your own, and then we'll talk about it.
Oh, I'm such a dumbass.
So find
No
your large
joke.
intestine.
I've been hearing things
Try to
lately.
identify the 4 major layers. There's no serosa. It's not a big deal. Sometimes that's missing. Sometimes it's not. But try to identify your 4 major layers, and then we will go from there. there's no oblique muscle layer in the large intestine. But otherwise, it looks very similar in a lot of ways.
It's just like
Layers labeled.
Pirates. It's a pirate. That. The octopus captain in Pirates of the Caribbean.
Mucosa, right? Yeah, this is the mucosa, right? What layer is this? Submucosa. Yeah, it's a submucosa. What layer is this?
The muscularis
Muscularis externa. And then what layer is this? Serosa. That's serosa, yeah, right? The serosa. So I have all 4 layers there, right? So how did your guys' labeling compare with ours that we just did together? And then of course you see all of these hollowed out cells. What are these guys? We should be used to seeing these guys by now, all over the mucosa. What are those? The goblet cells, yeah, right? The large intestine is just jam-packed full of goblet cells, right? So we see lots and lots and lots of goblet cells. And then of course here we see that the submucosa happens to be sort of folded up with this as well. Like we've got here where it's a little flatter out. Let's zoom in just a little bit more. Just a little bit more. Light. Okay. By doing that, we can see that layer of smooth muscle right here. Who's that? What's that layer of smooth muscle called that's part of the mucosa? The muscularis mucosa, right? Yeah, it's the muscularis mucosa. Right? So everything's there, everything fits, okay? And then of course if we moved into the submucosa, we can see all of the connective tissue and everything else, right? So we see everything else in here like this. And kind of moving through, big blood vessel right there, for
are layers of muscle. Again, just like with the small intestine, your two layers of smooth muscle are pretty easy to tell apart. You've got your inner circular layer and your outer longitudinal layers of muscle. One thing that is apparent here is there's a little bit of connective tissue kind of sandwiching those two layers together. In a few of the slides that we looked at the other day, those layers were coming apart. So don't be alarmed if you see that. That must just be an artifact of the tissue preparation. But there is a little bit of connective tissue between those two layers. Right? So we've got our inner circular and our outer longitudinal layer. So take just a second. Let's spend a few more minutes with this guy and let's identify those key features, right? It's like the musculature. We now know that we're absorbing nutrients as well. We're absorbing vitamins and stuff like that. So we're still moving things from the external environment to the internal environment. So it shouldn't surprise us then to see Peyer's patches in the large intestine as well. And you may or may not see Peyer's patches on your slide. Some of them are actually kind of big. This one's a little teeny tiny one, but you might see these on your own slides. Come back to the gross anatomy of our large intestine. Back over here. Look at our large intestine. One of the things that we see on our large intestine is we see that the large intestine has this band that goes all the way across. What was that band called? Remember? It's called the tenia coli. Okay? The tenia coli is the longitudinal muscle in the large intestine. In the stomach, in the small intestine, the longitudinal muscle goes all the way around, just like the circular muscle does. But in the large intestine, the longitudinal muscle exists as a singular band called the tenia coli. So when we go to our microscope, we see that it has those two layers of muscle. That's because that section of tissue was taken out of the tenia coli. If you were taking a section from up here, for example, it would only have a circular layer of muscle because there's no longitudinal muscle. So this tenia coli is just this thin strip of longitudinal muscle that runs through the large intestine. I don't know why it doesn't exist. Anyway, you kind of see that. We have a couple of other models here. Or another model. So a few of you guys have asked me about this model. I told you your weight. So your weight is over. You're lucky. Today's the day. So this model is kind of an interesting one. The idea behind it is that it's showing us a cross-section of our GI tract through our esophagus, through the stomach, through the small intestine, and through the large intestine. I admit that I don't like this model for a lot of reasons. Some of them are flat wrong. Not my reasons, like some of the things in the model are flat wrong. I'm going to give you guys an example and a quiz. So let's take the stomach for example. Let's take this region right here. What's wrong with that cross-section of the stomach? You should be able to get your layers by now, right? But what's wrong with that cross-section of the stomach? There's something really wrong with one of those layers.
star for the day. Yeah, indeed, right? Look at the muscularis externa of the stomach. How many muscle layers are there? You see circular, we see longitudinal, but there should be oblique, right? It's not here, right? So for whatever reason, when they made this model, they just like decided to leave the oblique out. I don't understand why. So like I don't really like it because there are some things that are flat out wrong. In the small intestine, I don't really like the small. I mean, I guess they show the villi, but I don't know. There's something wrong with the intestinal crypts. Maybe the vibe just but nevertheless, you know, it's got the muscle layers right and stuff, but I don't know. Let's just look at your YouTube. What I do like about this model, though, is I like the large intestine. Okay, I like the large intestine. And I'll explain why I like the large intestine in this model. Right? So again, ignore everything else. Just look at the large intestine. Look at both sides. And what do you notice about those two sides? It's maybe different from each other. Then a quiz. One of these things is not like the other. You guys are practicing. How do you see it? Is it running down the middle at all? No. There's no longitudinal muscle? There is, right? It's right here. There's your longitudinal muscle, right? Down here, you've got your circular muscle and you've got your longitudinal muscle. But if you come up here to another part of the intestine, you've only got the circular muscle. There is no longitudinal muscle, right? So this does show the tinea. I think it actually, I mean, we're kind of impressed with the way that this model shows to show the tinea coli. It's very creative, right? But it does show the tinea coli because down here, you do have that layer of longitudinal muscle. That is the tinea coli. But up here, we notice that it's missing because it should only exist in that little band that you see right along here. And that's what you see in the intestine. They actually did, I think, a pretty good job. They really fell short, I think, in a lot of other places. But on the large intestine, I think they really hit the nail on the head by showing the tinea coli. Just kind of keep that in mind when you're looking at this model. It does show the tinea coli really, really well. All right. So, any questions about the large intestine? Spend 3 or 4 more minutes with this, and then we'll move on to something else. Turn some models here.
You like this food?
So the stomach is only or I guess this is one region where there's 3 layers of muscle. Yes.
Huh?
I do want to try to stay there. So I take 5.
Oh, that's too good.
Why don't your voice go high?
Oh, why are you doing that? Yeah.
No, I'm saying that's when people lie when they're like, what's that? You know?
And is the Peyer's patch right this kind of equivalent to the Orion, the 70+? So wait, no, that has to be so the Peyer's patch is kind of equal to Orion, right? No? So that's
So it always does that.
yeah.
Uh-huh. Yeah.
It's probably the official slides.
All right. So the large intestine, I mean, it's got its own quirks, just like just about everything else. Right? It's got its own quirks and stuff like that. But that does get us all the way to the end of the gastrointestinal tract. Okay. And now we've got a couple. We're almost there. Just a couple of accessory organs left to look at. We're going to be finished with our digestive systems. We're really close. You guys are over the hump. We're almost there. The next thing we do want to look at though is the liver. So let's take a quick look at this. I know that many of you have already started the gross anatomy of the liver, so you can help me out. So these models all sit a little funny. The liver, of course, sits in your body like this. So if this person were looking at you, the liver would be sitting kind of like this. So what lobe of the liver is this one? It's the right lobe, right? What lobe is this one? Left. Yeah, right? If we turn the liver around, let me see. What's this lobe? We got two in the back that sound very similar to each other. But this one's in the back. The back. The back. Well, Christian? Caudate. Caudal means back or rear, right? Like the tail of a fish is called the caudal fin, right? So the caudate lobe is in the very, very back of the liver, right? It's actually right next. It's in the very back of the liver. It's right next to this big blue blood vessel that we spend a lot of time with in the cardiovascular system. Who's this? This is your inferior vena cava, right? Your inferior vena cava. We'll talk about the blood flow through the liver in just a minute. But yeah, this is the caudate lobe that we're looking at here. And then if we turn the liver over and we look at the inferior surface, we see one final lobe of the liver right here. What's that one? Quadrate lobe. Okay? So two lobes with very, very similar names. We have the caudate lobe in the back of the liver, and then we have the quadrate lobe right here. Quad, right? Four sides, right? I always remember this one because it looks almost like a perfect rectangle, so that's kind of how I remember it. I think about it as having four perfect sides. The quadrate. Quad is in four, right? So this is the quadrate. So the liver in the digestive system has two kind of primary main functions. One of the things that it does, we mentioned this morning, is it produces bile that will work to digest fats, or at least break up fat droplets so that we can digest them. The things that are green on this model are associated with bile. And then, of course, the other main function of the liver is the fact that we have that hepatic portal system that we have to deal with, right? So I know that we haven't thought too much about the hepatic portal system in a few weeks. You guys will remember this model from a few weeks ago, where we saw that the hepatic portal vein is the one that we see right here. Remember, that's the one that's draining the digestive organs of blood and sending that blood to the liver, where we can detoxify the blood. We run into foreign substances. We can hopefully help get rid of them in the liver. But we also are going to be pulling out excess nutrients like glucose and storing them in the liver in the direction of so we're going to be doing a few different things, but we have to send that blood to the liver. So if we look at our liver model, look at that. Look at this purple vessel right here, right? That is our hepatic portal vein. So these guys go together kind of like that, is roughly how they go to, there'd be some space, but they roughly go together like that to where those hepatic portal veins match up. So this is the hepatic portal vein leading into the liver, and we see that it branches into multiple capillaries. The hepatic veins are going to gather that blood and they're going to dump it into the inferior vena cava. So these are your hepatic veins here, dumping that blood into the inferior vena cava. So we're sending it through the liver and it's filtered through the liver and ultimately it's dumping that blood into the inferior vena cava. We have a branch of the hepatic artery right here. So we have the hepatic portal vein, we have the hepatic artery, and we have a little bile duct right here. We'll talk about the bile ducts here in just a moment. Keep these three things in mind though. They're almost always found together in the liver, both on a gross anatomical scale like we see right here, but also on a microscopic scale. We'll take a look at that. So the liver makes bile. And that bile is collected by the hepatic ducts. Right? The liver is a duct. Bile is collected by hepatic ducts. Let's zoom in on these guys. Let's see what they got. So you have a left hepatic duct right here. We have a right hepatic duct right here. Those two ducts come together and they form this very, very short common hepatic duct that you see right here. So left hepatic duct, right hepatic duct, they come together to form the common hepatic duct right here. Okay. Now, that common hepatic duct would lead out of this area, and it would take the bile to the duodenum. In fact, you can see there is a bile duct right here in this model, taking that bile to the duodenum. It would enter at that duodenum just where the pancreatic duct also leads in. But remember that hiding underneath here is that hepatopancreatic sphincter, right? So when you're not digesting a meal, that hepatopancreatic sphincter closes tight to allow that bile to the duodenum. It's only when you eat a fatty meal, when you're digesting a meal, I guess I should say, that sphincter opens and it allows for things to go into the duodenum. Most of the time it's closed. So the liver doesn't stop making bile. So instead of allowing the bile to flow freely through that duct, it's closed at the other end. So what happens is when the liver makes bile, it actually backs up and it is stored in the gallbladder. Okay? So the gallbladder is a storage organ for our bile. I think sometimes correctly the gallbladder makes the bile and it's not in the liver, but it's stored in the gallbladder, which is a fairly large organ. For what it's worth, bile is very green, so this color is accurate. We don't always use accurate colors, but bile is really, really, really green. If we were doing a dissection, you'd find the gallbladder in about 2 minutes, because it's as green as it can possibly be. It stands out. The duct that leads to the gallbladder is called the cystic duct. So we see the cystic duct right here. So there's a lot of ducts in this area, and they all have very similar names. So remember, you have the left and the right hepatic ducts. You have the common hepatic duct here, which on this model is very, very, very short. You have the cystic duct. So when that common hepatic duct and the cystic duct come together, they form the common bile duct. And the common bile duct is what leads to the duodenum. So this model shows the common bile duct. This model shows the ducts a little bit more clearly. It kind of spreads them out a little bit more. So you have the left and the right hepatic ducts. You have a much longer common hepatic duct right here, and then you have the cystic duct right here, which leads to the gallbladder, and then this would be that common bile duct. Okay, I've drawn this on the board so you guys can kind of see how they come together. It's helpful to see it labeled before you try to start labeling itself, because there are a lot of ducts. Some of them are very, very short, and they have very similar names, so it's better to look at. when we look at the liver under the microscope, so when we take a section of liver tissue, what we see is that the microscopic anatomy of the liver actually very closely reflects what we see with the gross anatomy. So this model is one that I know that you guys have already probably taken photos of. But let's take a really quick look at this guy. So when you look at the liver under the microscope, we see that it's organized into these hexagon-shaped lobules, right? So this is a hexagon-shaped lobule that we see right here. There's another half of a one right over here. There's another one up here, and there's another one here, and so on and so forth, right? At the corners of those lobules, so right here and right here, right here and right here, we see what we call the portal triad. Okay. Notice that at the corner of each one of these, I have a little tiny purple vessel. I see a little green guy. I see a little red guy. This is a branch of the hepatic portal vein. This is a branch of the hepatic artery, and this is a branch of the bile duct. So the bile that's being produced by these hepatocytes is getting collected by this bile duct. But the hepatic portal vein is actually branching into capillaries, and those capillaries are going to filter our blood. They're going to remove nutrients, and they're going to send that filtered blood to this vein, which is called the central vein, which will feed into the hepatic vein and then ultimately into the inferior. So these lobules are essentially the filters of the liver, but we're sending that blood towards the central vein, towards the central vein, towards the central vein, towards the central vein. Okay. So these capillaries are called sinusoid capillaries, liver sinusoids, and that's where we're removing those nutrients, that's where we're filtering things. So what we're doing here is we're taking a little portion of one of these lobules and we're sort of blowing it up on the other side of this model. So that's what we see when we look at this, is you'll notice here you have a corner of one of your lobules. This is that triad. So we have the hepatic artery, we have the hepatic portal vein, and then you have your bile duct. And the bile duct is easy to pick out because it's made of cuboidal epithelium, right? So that will be easy for us to find. And then those liver sinusoids, that blood travels through these capillaries, and the hepatocytes, these guys, are pulling out the glucose from that blood, storing it as glycogen for later use, and then the blood eventually makes it over to that central vein, which is way down here in the corner of our model, and we send that blood to the hepatic vein. There are a lot of macrophages in here, and if we blow this up a little bit, you can see these little guys. This is a macrophage right here. There's another couple of them right here. There's one right here, and so on. And there's another one right over here as well. So there's little macrophages in those sinusoid capillaries that allow us to potential pathogens. So it's kind of an interesting little set of capillaries. But when we talk about your liver being a filter, these hexagon-shaped lobules are the filters. Okay. So what I would like us to do is I'd like us to look at the liver under the microscope and take a look at these lobules, hepatoportal triad, central vein, and so on and so forth. So you guys would do me a favor and go grab a slide of the liver. We'll go ahead and take a look at it. Vein is always going to be the biggest. So this guy right here, I don't even have it in my full field of view. I kind of did that on purpose. But this guy right here is going to be my hepatic portal vein that we see. The hepatic artery is right here. It's usually the smallest of the three, and they do tend to hide from us a little bit. But that's a hepatic artery right there. You know it's an artery, A, because it's small, B, because it's got that thick tunic and get around course, our bile duct is the one that has cuboidal epithelium around it. This is your bile duct right here. So here we have our entire portal triad. It looks like probably the hepatic portal vessel is actually branched into a couple of smaller veins. But the big one, of course, is the one that we see right here. The artery is very, very small in the bile duct. So take a couple of minutes. Try to find your own portal triad. Portal triad. Assemble. Artery. Bile duct. Vein. I don't know where to go with that. But it sounds like it should be a superhero name.
Animal control.
It's like a banana phone or something?
Yeah.
Or repeat what you said before you walk closer.
Hello?
Go
Animal.
for it.
It's for me.
Go for it.
No, man. I'm alright.
Yeah, actually, one
Gotta
next
get
to
our
it
plates
is better. One next to it, yeah. They're all three. So we're gonna- Got it? Good. How we doing over here? Good? You've been using the transverse colon to call the portal triad?
Mm-hmm.
That seems
How'd
appropriate.
you know?
I just,
You've done it
Actually,
before.
what was she?
it's, I just took a wild stab at things.
She was calling the. I don't know what she
Okay, now you're in the joke. Cause
Yeah.
Typical Canadian.
Transverse colon.
All right. So let's find a portal triad.
It's not
Yeah.
funny.
Let me see the spread.
What? That looks like the aliens from Chicken Little.
Of course, you watch Chicken Little.
You did it?
I watched Jimmy Neutron in the movie with the
Yeah.
chicken dance.
Portal triad.
Chicken Little's a movie.
I know it's a movie.
Why are you so angry all the time?
Fighting off boredomus.
Yeah.
I agree.
You would think I would be the moody, angry one.
You are. You just turn it off.
I'm full of love and life and happiness and whimsy. I can hold eternity in the palm of my hand.
I know the sun turns all the time.
No, you can't do it.
The power of the sun.
He's like, this sun is fat. And you go like,
The power of the sun. And the power of my hand. What movies are from?
girl, I don't care. It doesn't matter.
Christian movie. You know who that's from? Straight Into Hers. Really? What movie is it?
From that one movie.
Chicken Little.
I'm sure you're right. Which one? Power of the Sun. Who's on Christian? Who says it?
I forget names stuff too.
Oh, the fuck ass guy. Is that what you're talking about?
Guys. Oh, don't shake your head. You don't know what's
I do know what you're talking about.
now.
Those portal triads should be at every corner of that hexagon-shaped lobule, right? So we should hopefully be able to find a place where they're all sort of leading to a central vein, right? So this isn't perfect, but it's pretty dang close. You've got a portal triad up here. You've got a portal triad right down here. You've got another one right here. And if you look, they're all kind of pointing at right here. They're all kind of going in this direction right here. And they're all pointing at that singular central vein that you see right there. So those sinusoid capillaries, if These are all of the capillaries that are making up this area. You see all those little channels in there. Those are all the sinusoid capillaries. They're all pointing at that little central vein that you see right there. So that central vein would, of course, be collecting the blood, sending it to the hepatic vein, and then the inferior vein. So try to find a central vein. And if you see the corners of the lobules, that's even better. But try to find a central vein. This is better than I found in my morning one.